Welcome to physics. We are now starting our next unit on waves and technology. So, today is our introduction to waves, and the topic is wave basics. And then we're also going to be doing a little PhET lab to kind of be able to play around with and explore the basics of a wave. So, our goal of this activity is to be introduced and maybe start using some of the scientific vocabulary for wave properties and behavior. And then our next goal is to be able to predict the behavior of waves through varying mediums. And so we're going to learn what that means, but also then make some predictions and just in general become familiar with some of these basics. And so some of the basics that you're going to really want to focus on is frequency, wavelength, and amplitude. And again, those might sound familiar to you, but they might not. And so hopefully, regardless of where you're starting at, you're going to feel successful with this and have at least somewhat of a visual of what we're talking about. So the first activity then is this wave basics reading. I've got this one-page little article for you that was created for the Beaverton School District. And so I really do want you to read it as it'll expose you to different vocabulary and then it'll give you some examples and explain it. And then I have questions here. So you can see 1, 2, 3, 4, and 5 questions. And that's going to correspond over here to the right that you can scroll through the questions. So some are going to be short answer, some are going to allow you to show your work, but you don't really need to unless you want to reference some of the information in the reading. Okay. Then I included these resources. You can see they're actually down at the bottom of this handout, and they're completely optional. But if you're interested and you're like, "Ooh, I really want to know more," then please check these out. We are going to dive deeper into waves eventually as we progress. So, I would really encourage you, if this made no sense at all, to actually take a look at these as well to help you kind of start to understand some of these basics. And then you have this string waves on a string PhET lab, and so we're going to be looking at a wave and some of the behaviors of a wave based on some of the vocabulary that we're learning. So um, activity 2, and I labeled the directions step by step here for you in bold. And so number 1 is open waves on a string. So you're going to click this. And here you go. Here's the little lab. So then step 2 in the top left, set the activity to oscillate. Top left, there you go. You're going to see that this is going to start moving for you. And in step 3, top right, set to no end. There you go. It's going to look like that. And I have a little diagram here to help you with that as well. And then I would encourage you to do slow motion at least somewhat of the time. It can really help you kind of slow it down and see what's going on. There it is. And that leads us to question 6, but it's our first question of this activity. Use the amplitude slider and observe how the string and waves change. So then you're going to try and define amplitude in your own words. So we have the amplitude slider. And some things that help you, you have a ruler, timer, reference line, okay, that you can move up and down, different rulers, okay, to help you out as well. But then so to kind of define amplitude, you can set this as high as it can go, and you'll see that there's a change, and then you can set it as low as it can go and see that there's a change. Okay, so again, pretty low, really high, and you can see that it changes the the wave I don't want to give the answer away, but it changes the wave. So then try to describe basically and define what is amplitude. Then I want you to do the same thing with the frequency slider. So describe what is frequency. And we talked about it a little bit up here in the activity. Okay, so you can use that. But now I want you to see it and kind of observe it for yourself. So I would set the amplitude maybe just back to what it was kind of at. I'll hit the play button. And then again, frequency, I can go super fast. Woo! And it looks a little more impressive when you take it out of slow-mo. Woo! And then you can slow it down, right? So kind of describe what is frequency, how does it change the wave? And question 8, now use the damping slider and observe how it changes. So we just kind of want some standard wave going on. So we've got this pretty standard. You can see that there's the damping tool right here. Go ahead and set it to none would be my recommendation, and you can see kind of what happens. You got to let it do a full rotation. So as a reference, we can go right to the top, and you see here that it's going to hit that red dotted line, and then down here you're going to see that it hits the red dotted line. And so that's important, okay, that this is damping and this has no damping. So now as you increase this, what happens? Let's go about half. How about that? So this green ball still gets to that red dot, and this one's hardly moving. Now, lots of damping. You can see that almost halfway through, the wave is not continuing on through this medium, right? This could be water, this could be air, this could be a steel bar, okay? Whatever material that this is, and it has lots of damping and the wave is not continuing. So that's really what I want you to make sure you observe there. And then some materials, waves are going to travel through easier. And so you're going to see that the entire material allows for the wave to travel. So describe that in your own words. And then I just touched on it, but how might the wave medium impact a wave? And that's really going to relate to question 5, which you've already answered, and question 8 that we just talked about with damping. Last but not least, I want you to hypothesize, will sound waves travel faster through water or air? And maybe try to explain why or think about why. And that's it. So that is our introduction. Let me know if you have any questions, and good luck.